Hey everyone, welcome back. Today we're going to be taking a look at render picking, and specifically how to use render picking in TouchDesigner with instancing to be able to edit instances individually and interactively using the mouse or any other type of multi-touch or other interactive setup that you might have. So let's jump into things. This is just used for my title. So let's take a look at our actual project, which we'll be rebuilding completely. So what render picking lets you do is, if I view my project window, render picking will allow us to use the mouse to actually move and edit different instances individually. And it does this by basically looking where the mouse is and performing under the hood ray tracing through your geometry scene to be able to identify the geometry that you have selected with the mouse. And then you can use that information to perform computations and make some edits on your geometry. So right now I have it set up that we can click to change the color, and then click and drag to actually move the instance as well. There's a ton of functionality that you can use render picking to achieve, and this is really only going to scratch the surface. It is intended to give a brief overview of how to get this technique set up and illustrate a little bit of the possibilities that can be used to kind of prime your creative intuition and hopefully get the juices flowing on your own projects. So, without further ado, I think I'm just going to rebuild this entire thing from scratch today. So first, we need a instancing setup. And so to do that, I'm going to just drop down a grid, a geo, or actually, I'm going to delete that geo. We're just going to need a grid with a null. And then I'm going to actually use a box as my geometry, which will be instanced. So I'm then going to middle mouse and drop down a geo. We'll grab a render top, Alt-N for the automatic null. Then we'll add a little camera and a light. Finally, I'm just going to put a Phong material onto my geo, and there you have it. Now I'm going to make this box just a 0.1 scale, and now we can turn instancing on our geo. Now I'm going to use the grid to lay out a grid of instanced boxes that we can start to mess with. But before I do that, I'm going to use sop to chop and then a chop to top. And that's going to give me chop data as soon as I switch this to RGB format. That's going to be the positions of these vertices as laid out by the grid, which you can see by opening the viewer and pressing W for wireframe. And I'm going to, just use this top, which I will drop a null after and rename pose. And we're going to use this to translate our positions. Now, the reason that I didn't want to use just this null directly is so that I can do some more interesting things in between our initialized points and our endpoints, which will be helpful later on. And so putting us in chop space will let us use GLSL and some more interactive feedback loops. So, make sure we are on our right plane here. And I'm actually going to translate, I think, whoops. Okay. Okay, so I did this with RGG by mistake. It should be RGB. And then I'm just going to turn this camera back to perspective and put it back where it was originally. Alright, so now we got our camera. Okay, one of the great things about using this top world is that I can just use a point transform and just use the uniform scale on this point transform to zoom in our grid a little bit. Now I'm going to change my render resolution to, well, I guess I can parameterize it. I'll get rid of these other parameters that are here, and we'll parameterize our render resolution. Make it 1920 by 1080. And then for our grid, I'm going to make the size X to be 1, and then the size Y will be me.par.x times parent.par.resolution 1, or resolution 2 rather, divided by parent.par.resolution 1. And resolution. There we go. So now we have an aspect corrected grid here that we can also keep zooming in a little bit more. And so this will just give us a nicely laid out little grid of instance boxes that we can then work with. Maybe we want to give a little bit more columns to our grid, and I think that's good enough for now. We can change all of this in a second. Now I'm going to go up one level, and I'm going to change this from a base to a comp, or sorry, a container rather. And that is so we can open our parent viewer, which we will need to set by just using this background top here. And then we'll want our viewer width and height to be the same as our render width and height in this case. Okay, so now we have a viewer, and I will just turn off that background. Okay, so now here is a viewer that shows all of our instanced boxes. And just to make it a little bit kind of more clear what's happening, I'm going to drop a noise down. We'll leave monochrome, we'll output just the noise. I'll use a speed chop, which I will then drag and drop onto the noise transform. And you'll notice that when I did that speed, speed here, there are these arrows, and I was able to drop it down with this constant attached. That's using the function store toolkit, which you can grab on his GitHub for free. Highly recommended. This is just going to give us a nice little slider that we can use to control our speed. And then I'm going to drop a math after this. That math will just multiply by 360, and I'll turn this to a 32-bit float. We can open the viewer and press N, and we can see that our values are indeed going between 0 and 360. And then I'll use Alt-N, I'll drop a null. I will call this rotation, or rot, and we'll use this RGMB to rotate all of our different boxes. And this will just give us a little bit more visual interest, and we can see that things are continuing to move. Okay, so now we'll just clean this up a little bit, and now we have a nice instance set up. So I will use Alt, click, and drag, and with that I will drop down this annotate comp, and I'll just call it instance setup for some organization. Now I'm going to do that same Alt, click, and drag, and this will be the render pick set up. So there are a couple different ways to use render picking. I'm going to use the Render Pick DAT today. And so to do that, we need some input. We can use the multi-touch in first. And if we click include mouse, that will let us use our mouse to actually interact with the viewer, and then use mouse information as multi-touch information. Now we need to assign the panel, and so this is why we needed to make our parent a container. We'll just use this to assign it to the parent panel, and now you can see that when I'm rolling over this open viewer of our parent, the X and Y and UV values change in our multi-touch in. If we have include mouse off, this doesn't work, so you need include mouse on to be able to use a mouse. You can also, as you see when I click, that select value goes from 0 to 1, so we can use that. And there's a bunch of other information that you can read about in the documentation. Now we can drop a Render Pick DAT. There it is, a Render Pick DAT. And the Render Pick DAT will require also a render top. And so we can use our render top just like that. And you can see there's also a bunch of other custom information here, but for right now, we're just going to keep it simple and use this render pick mostly with default parameters. Now, if you'll recall, what render picking actually does is use a custom algorithm that is under the hood to actually take your UV position of the mouse in viewport space and raycast to intersect with your geometry and understand which geometry that mouse is clicking on or hovering over, and a little bit of air quotes there, for the specific scene. And so that is why it requires a render top, because we need to know what render scene to kind of pass that ray casting through. So for our render pick, we use, right now, just render 1. And then if we look at the documentation for this, we can see here that you feed it a DAT with minimum 3 columns, select U and V, and that there's commonly multi-touch in DAT that's used. So that's why I'm using the multi-touch in DAT here, but you don't have to do that. You can use any DAT with select U and V as columns. And so now let's take a look at what's actually happening with the render DAT itself. Right now we have it set to while select as the strategy here, which means we don't see anything as I'm hovering. But if I click, all of a sudden we can see, one, the geometry that we're clicking on, and then right now some position information, TX, TY, and TZ. The options of the render pick will let you choose what position you're getting returned. You can decide if you want the normal as well, and then these other attributes, as well as custom attributes, which I'm not going to go into right now. So I'm going to turn on Fetch Instance ID, because we are instancing. And so now, because our strategy is set to while select, if I go and select an instance, we can see the instance ID here is being calculated as well. And if I click on a bunch of other ones, then we can see a bunch of other instance IDs show up. If I click somewhere with no instance, we get a -1 for our instance ID, which is handy to know whether or not an instance is selected. You can change the strategy to always, and now you can see that the values are kind of constantly updating, and specifically, our instance ID over here in column 8 is also constantly updating as we're moving around the screen. So this is also important because sometimes you might want one functionality, sometimes you might want the other, and so it's good to know kind of what the difference is there. Quickly going over these parameters, pick radius is going to be how far away from the UV point your render is scanned, as in how far radially away from the UV point there are actually rays cast in the raycasting algorithm. So higher means better coverage, and then pick radial step and circular step are going to be kind of like your resolution for raycasting. So if you think about a circle being the radius, they're going to cast rays on spokes going out, and so that will be your circular step, and then, or rather the radial step, and then it will also cast rays based on concentric circles going out from the point, which will be your circular step. So smaller is a higher resolution, more dense grid there. So now let's actually do something with all of this information. I'm going to put a null after the render pick. And so at this point, I think the easiest thing to do, and what we can do first, is just change the color of some instances based on us hovering over them. So I'm going to drop down a constant, and that constant will output with just the resolution. And this constant is going to be our color. So we'll go over here to our instance page. We will turn on the color. And so now we have a slider for our instance colors. I'll make it just white again. And so our goal is going to be to change one instance's color individually by clicking on it. So I'm going to start by just transforming this null into a DAT. So this will have all of my good stuff. And so I'm only interested in a couple cases. I'm interested if the instance is non-zero. And while I'm in always mode, that's really all I care about. So what we want is when our instance ID is non-negative, then we want to update the corresponding pixel in this shader with some other color. And so I'm going to first get a select, drag that constant onto the select. I'm then going to start a little feedback, which will have a GLSL and then a null afterward, which I'm going to call color mask. And then this color mask will be the target of our feedback. Now, we'll use this GLSL shader to pass in data from our events and then update instance data based on the render pick events. So for example, what I can do here, I want to change my DAT to be channel per column, and then have our first row is names and our first column is values. Now we can just grab the instance channel, and you can do a couple things to get rid of these empty rows. The multi-touch in-dat is kind of set up for using touchscreens and areas where there could be multiple touches at the same time. So there are 10 rows displayed by default. I'm just going to move that down to 1 because we're just using the mouse right now, and so we only expect 1. So now we have our instance, which updates as I roll over the viewer. And then I will call this touch data for the null. Now I'm going to go in and actually create an array that's going to be a vec4. I'll drop that chop onto the chop, and then I'm going to name it stouchData. Now, get our editor up here, and so we can start. So first we need to declare a uniform sampler buffer, and we'll call it sTouchData because that is what we just set up here. Our color is going to be our first input. And then what we want to do is grab instance ID, transform instance ID to XY, and then update the instance color by changing XY pixel value. So first we'll grab the instance ID, and so this is going to be using our TouchData sampler buffer. So we can declare a vec4, and we'll call this TouchData again, I suppose, equals texel fetch. And here we're going to grab our sTouchData, and it'll just be the 0 or first input because we just have one channel. You will need to update that if you have a multi-channel. And then we can say int ID equals int touchdata.r, just like that. We can then further say well, actually we don't really need to do much more here because in our chop to top we have all of our points just lined up in one nice little line. That is, in this case, 680x by 1y. So we know that our y is always going to be 0. So let's say we can do something like an if statement here. We can say if ID equals, and then we'll make an int here, and we'll say gl fragchord.x, and if, well, actually that's all we really need because we have all of our instances all lined up. So if this ID equals our gl fragchord.x, then what we want to do is change the color. And so I will just change the color to be, let's say, red. And so to make this a little bit more clear, I guess, we can say int x equals ID, and then we can use x in our inequality there. And so then all we need to do is pass out our color. I forgot to change this to a texture buffer instead of an array. And so now all of that is working well. So now we can start to see what happens. We can see in our color mask things are changing, but I forgot to just drag and drop that in here. Now you'll see we have an error here that there's a cook loop. So to fix that, I'm just gonna drop a feedback into my chop chain, which will remove that. And now you can see as we're rolling over our instances, we are painting them red as we do so. I'll reset, and we can just do the same, and you can see that it works very well. And this is pretty simple to set up. So I'm just going to, that was Alt, click and drag, which will drop a select. Again, using the function stores toolkit. And so I'm just gonna call this update color from Render Pick. Now, we could, for example, change this render pick to while select, and that means that I'll be able to actually click, and I can click and drag to paint, or click on individual boxes. It's kind of up to you, the behavior that you want. I'm going to keep it on while select, or actually I'll just put it back on always for now, because the other thing that I want to do is be able to update my position. So if we're going to update the position, what I want to be able to do is click and drag for the position and just use my left click here to do color. So right now, there's nothing going on just to identify whether it's right or left click. So what I need to do is go into this Render Pick DAT, and use this option Merge Input DAT. And what you'll see is when I click this, we get all of our input data from the multi-touch in as data coming out of our render pick. And this will give us UV, but it will also give us this little channel aux, which when I right click is 1, when I middle mouse is 2, and when I left click is 1, when I middle mouse is 2, and when I right click is 4. And so we can use that aux data field to determine what pointer or what click is being used, and we can then use that to determine whether we should be coloring. So I'm going to say I want to color on right click. So I'm going to select not just instance, but aux. And then I'm going to rename to instance and button type. And so now all I need to do is go back to my code here. And because I'm already reading in all of this texture buffer, which we have 4 channels available in, I can just type another variable, which I'm going to make a bool, and this will be called right click, and it will equal a bool, and that bool will be evaluated based on casting an int of our touchData.g and seeing if that is equal to 4. And I'll just annotate this by saying we test for right click by checking length with 4, which is the input data index for right click. See multi-touch docs. Okay, so now we have this bool here, and so what I can say now in my conditional is just if right click double ampersand and our index ID is the right one. So now I'm clicking and dragging, or rather I'm rolling over, nothing. I click and drag right click, nothing. But then I right click and maybe I will do a quick mouse in so you can see. Okay, so hovering, left click, nothing. Middle click, nothing. But when I right click, it is changing my color. And when I left click and drag, it is also painting. Exactly as I wanted. So that's pretty much done. And then what I need to do now is update in a similar fashion my position. So I'm actually going to just copy and paste all of this over here. And we're going to change it just to update position from Render Pick. I'm going to select here my point transform, which is my initial positions. And then we're going to update this to be called position mask. Alt click and drag for a select, and then I'm going to wire that in to my position. Now, when I reset, everything seems to be working so far, so this little change up did indeed work, but I need to edit this GLSL. So now we need a little bit more information. We need not only the instance and the button type, we also need direction data to understand how to move our position. And we get that actually out of our render pick already with this tx, ty, tz. And so what I'm going to do is select those channels using pattern recognition here to select channel TX and TY. I'm then going to grab a slope. And so this is going to give us the change in direction in both X and Y. And then I'm going to use a merge here. Oops, not a median. A merge. And so now we have 4 values. And so this will, again, fill out our vec4. And so we'll be able to use the X and the Y to then move our instance position. So let's update that a little bit in here. And we will grab instance position move info. And so this will be a vec2, which I'm going to call move xy, and this will equal touchdata.zw. And so that's going to be the last 2 channels of our buffer. And maybe up here I'll come and I will say instance ID, click type, txty. Just to be clear what information is in this buffer. Now we don't want to update the color, so I'm going to just change this variable here from a color to position, and just update that the whole way through here. And now, instead of setting our position to something new like this, we're just going to say position plus equals move xy, and I'm going to say times something small, like maybe 0.05. Seems we have an error here. And that's because this should just be pose.xy. And now everything looks right. I will reset. And okay, so we can test one just rolling over, doing nothing. I can still paint with clicking and dragging, but we can see this motion is occurring. And so, okay, we want the moving to be not with our right click, but with our left click, which is just 1. So we'll just update this documentation. Maybe we could do it a little bit more configurably with something defined. And I'll define the click type as 1. Left click, 4 equals right click, and 2 equals middle click. Okay, so then I can just say click type here. And I'll just update this to test for click type match. And so anyway, now that this is set to 1, we should be able to left click and drag, which we can do, but we can see we're repositioning a bunch of these instances and not just the one that we click on. And that's because our render pick is still set to always. Now we could do a couple different things here to fix this, but the easiest is to just switch to hold on select, and this will let us actually click and drag on specific instances, and well, it should work. It looks like it's not quite working for some reason there. Perhaps we want to hold the last pict. Let's try and reset everything. Okay, so this seems to be something going a little bit weird. So let's maybe change the scale of our box even a little bit more so that we have some more space between them. And I think I'll maybe also reduce my columns again and then reset everything so that we can see our instances a little bit better. Now everything seems to be working except this click and drag isn't quite doing what I want it to. Alright, so I was trying to figure out what I was doing wrong here, and instead of selecting this XY, because this is actually giving us our SOP positions in SOP space or world space, I actually want these UV channels that I'll rename to TX and TY. And now, when I click and drag, we can see this nice smooth repositioning. And when I left click, we can see that I'm still able to click and actually paint the instances. Now, Render Pick, if you have on always, we can still kind of click and drag, but you can see that during the click and drag, if you click and drag over another instance, it kind of messes things up. So you can change that to hold first picked, and that will let you just click and drag and hold on to a singular object. If you wanted, you could actually do two separate render picks. That render pick one could be always and used for painting, and then render pick 2 could be set to hold for selection, and that could actually be used for our click and drag. So then we can right click and paint, or left click and drag, and all of that functionality kind of works as we would expect. We'll scale up the boxes a little bit, and this is pretty much it. So now you can see how you can use render painting to do some pretty unique instance editing and making it interactive. So I can see here, I'm just kind of like clicking and dragging all of these boxes out of the way here. And then maybe I'll put this red one in the middle just because I can. There's a ton that you could do. I think one easy extension that I'm going to leave as an exercise, because this tutorial is a little bit longer than I wanted it to be already, is to be able to enlarge an instance by middle mousing over it. So think about how you would scale up a single instance by middle mousing over it. And I'm going to start my next tutorial with the answer to that. And we're going to focus on using the Render Pick Chop instead of the Render Pick DAT, as well as expanding some of this functionality a little bit more. So until then, I hope everybody enjoyed this topic and maybe learned something. Thank you all so much for the support on Patreon. Like I have always said, it means the world to me, and it's really fundamentally changed how I can live my life. And so thank you very, very, very much for all of that to everyone who pays to support. For those of you that don't, I still appreciate you watching my YouTube videos. Like and subscribe if you're finding any of this helpful. and I will see everybody next time.